What happens when you remove almost all the water from a living thing? For most, it's a definitive end. But for a microscopic animal called a tardigrade, it's a temporary inconvenience. This process, and hydrobiosis, is a form of cryptobiosis, or hidden life. When faced with desiccation, the tardigrade retracts its 8 legs and contracts its body into a dense, desiccated ball called a ton. In this state, its water content can drop from 85% to as low as 3%. It isn't hibernating or sleeping, it has effectively paused the biological processes that define being alive. All metabolic activity slows to less than 0.01% of normal, making the creature a piece of suspended animation, a time capsule of life waiting for a single drop of water to resume its existence. This is the first fundamental tool it needs for what comes next. The vacuum of space is more than just empty. It's a violent environment, relentlessly hostile to complex molecules like DNA. Outside the protection of a planetary atmosphere and magnetic field, everything is bombarded by a constant stream of high-energy particles. These are galactic cosmic rays and solar radiation, protons and heavy ions moving at nearly the speed of light. When one of these particles strikes a DNA molecule, it can shatter it, causing double-strand breaks that are typically irreparable for most organisms. This is a death sentence written at the molecular level. Yet, when tardigrades in their ton state were exposed directly to this environment, something remarkable happened. They endured. This implies the existence of a protective mechanism that goes far beyond simple dehydration tolerance, a biological shield against the very fabric of space. Beyond radiation, space is unimaginably cold, approaching absolute zero. For a water-based life form, this presents a fundamental problem. When water freezes slowly, it forms sharp, crystalline structures, ice. Inside a cell, these ice crystals act like microscopic daggers, piercing membranes and destroying cellular architecture from within. Survival isn't about enduring the cold, but preventing this internal crystallization. The tardigrade achieves this through a process called vitrification. Instead of its internal water forming organized, destructive crystals, it becomes a disordered, amorphous solid, essentially a biological glass. The animal's cells don't freeze. They are preserved perfectly within this glassy matrix, with no sharp edges to cause damage. The tardigrade literally turns itself into a solid, stable glass statue to wait out the cold. The ton state is often misunderstood as a type of deep sleep, but it's far more profound. It is the almost complete cessation of metabolism. In this state, the tardigrade is not aging. The molecular processes of decay and repair, the fundamental ticking clock of life, have all but stopped. This is crucial because, in the vacuum of space, there is nothing to consume, no energy to be gained. An organism with even a tiny metabolic rate would eventually burn through its reserves and perish. By reducing its metabolism to a fraction of a percent of normal, the tardigrade effectively steps outside of time. It becomes a passive object, no more alive in the active sense than a rock, waiting for external conditions to reactivate its dormant biological machinery. This isn't just theory. In 2007, the European Space Agency's Photon M3 mission carried a payload of tardigrades into low Earth orbit. They weren't inside the capsule. They were placed in exposure trays on the outside, subjected to the hard vacuum and cosmic radiation for 10 days. Some were shielded from solar UV radiation, while others received the full, unfiltered blast. Upon return to Earth, the tardigrades were rehydrated. Those exposed only to the vacuum survived and reproduced as if nothing had happened. More astonishingly, a handful of the tardigrades that endured the full cocktail of vacuum and unfiltered solar radiation also survived and produced viable offspring. Subsequent experiments on the International Space Station have continued to test these limits, confirming that these microscopic animals possess a toolkit for survival that seems tailored for the most extreme environment we know. So, how is this possible? The answer lies in a suite of unique proteins found nowhere else in the animal kingdom. Many are intrinsically disordered proteins, or IDPs, which lack a fixed 3D structure. This flexibility allows them to form the bioglass responsible for vitrification, specifically proteins named cytoplasmic abundant heat soluble, or CAS. They link up to create a porous, protective matrix that physically prevents other proteins from unfolding and clumping together. But the most direct form of protection comes from a protein called DSUP, for damage suppressor. This protein is remarkable. It has been shown to physically bind to the tardigrade's DNA, forming a protective cloud around the genetic material. This protein shield doesn't stop radiation from hitting, but it physically protects the DNA strand from being broken, like a molecular armor. It is a direct, tangible defense against the hazards of space, engineered by evolution.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.